Aha, look at that. Like it's a real deal. Okay, let's do it. So welcome to the mostly still online, but a couple of us are in person March edition of Denver Erlang Elixir. As you heard the lady say, this is recorded. We'll, if I remember, we'll upload it onto YouTube for posterity. So what are we gonna do tonight? I'll make some announcements. Our speaker will speak. We will have the opportunity for some show and tell if anyone would like to do that. And then we will do Zoom breakout / have a beer in real life. So when I say show and tell, what do I mean by that? That is an opportunity for you in the group to share any problem you've had at work, something you discovered, you got a question. It's kind of like a lightning talk, but you just kind of, say, hey, I'm working on this thing. Sometimes we have people who share, sometimes we don't. It's just an opportunity. All right, so quick shout out to our sponsor, Pay It Off, who is paying for both Meetup and Zoom. Sometime soon, we may actually get back into the beer and pizza realm, but not yet. Coming. All right, who makes this happen? So hi, I'm Brett. I'm one of the organizers. I see Jeff, Jeffrey, and Dylan here. Alexandra's got her hand full, so will not be joining us tonight. But yeah, we try to make this thing happen every month. And amazingly, even when your speaker who was scheduled to speak today happened to be Ukrainian and had other things on his mind this month for some strange reason, had to cancel, and then our friend Todd bailed us out. We are there to try to make this thing happen. All right, how do you get hold of us? We announce our meetups on meetup.com. We have a presence in the Denver channel, which is really just redirecting you over to the Denver Beam Slack channel, which is kind of our own channel. You can join for free. There's a link in the top of Denver. We can help anybody join who wants to. The reason for that is that the conversations tend to stick around a little bit longer than in the general population. Does anyone have a general announcement? All right. If you would like to see Todd in the flesh, I suggest you buy tickets if there are any available. I have no idea if it's still available or not. It's coming up to a relatively, well, somewhat nearby Elixir conference near you. So that's coming up. And then 2 months after that, in the other direction is MPEX, which I will be attending over in Salt Lake. So it would be kind of a long road trip or a relatively short flight. So you guys should go to something in person. All right, so every month we ask a few questions to kind of cover the network angle. Is there anyone who's currently hiring for an Erlang Elixir position? All right. Oh, wait a minute. Someone in the crowd.
Yeah, we've got a bunch of roles because of budgeting that got kind of finalized late in the year. There's actually, I don't know, 6 or 8-ish Elixir type roles. I'm still working on my full stack role to get, right now it's listed as a New York role, but it's a remote role, so I'm getting it fixed. But I'm also, if anybody knows any Python engineers who maybe want to learn Elixir, I have a need for a Python engineer, but then you could also do Elixir stuff on it too. So I put that in the Slack. It's on the jobs channel. That's about it.
I don't know if this counts, but I saw Mackenzie from the.
Sorry, and I work for PepsiCo. PepsiCo Ecom. Thank you very much.
All right.
Okay.
Anybody else hiring?
I was just gonna say, not me, but I saw Mackenzie from the DC Slack or DC Elixir is got room on her team, I think, at next role for Erlang engineer. So that's pretty interesting. Those jobs, at least in the US, they don't seem to come up that much.
No,
so.
they're Erlang in the US is a tough gig. I will definitely attest to that, having done that myself. I did see also there was a job posting earlier last month. So if you look in our jobs channel, you can also see links to other things. So if you're looking, that's a place to look. Is there perhaps anyone looking for a cool Beam position?
Still on the hiring thing, an agency that I'm not working for, but I'm friendly with is constantly hiring both senior and staff roles. They tend to get a fair amount of Elixir work. So if that's more your
Okay.
bag, I mean,
That's cool. Yeah, if you've got links, post that.
they'll be, you know, leveled, but not Elixir specific, but I'll throw them in the Slack.
Sure. Okay. Thank you. All right. Oh, yes, my monthly plea for speakers. So Todd, thank you so much. Glad that you were able to practice and hone your amazing talk that you're going to give later this month. But you don't have to be a Todd. You can just be just somebody like me who like works in Elixir or wants to work in Elixir and would like to share his or her thoughts, feelings, experiences with a Beam language. So the bar is low. We're a supportive community. We will help you, coach you for a presentation. So at the moment, the rest of the year wide open. So we have lots of opportunities to speak. And for the foreseeable future, we're going to be online. So if you happen to live in Hawaii or some nice place like that, you still can join us, even if the beer might be local. So reach out to one of the organizers and we will happily sign you up and or help you. All right, so this evening for our amazing entertainment, we have Todd Resudek doing the Phoenix project, which it sounds like maybe it's just Phoenix, but it also sounds kind of stealth and exciting. So I'm not really even sure what that is. So I will, sadly, my mouse is not available because I'm sharing my screen. So I will stop sharing and hand it over to Todd and he can fill us in and see what that actually means.
Thank you, Brett. Let me start presenting here. Oops. Before I do that, I should probably share my screen. So I won't be able to see the Zoom while we're in here. So if you have questions, just shout them out. Don't put them in chat or anything.
Speak up. Todd is not shy.
I'm not too shy. I'm insecure, but not shy.
Yeah, therapy session after the talk.
Yeah, okay, so I assume you can see the desktop now. If not, this is your chance to
We can,
shout.
yes,
That's good.
over. We don't see
Yeah.
anything. There we go.
There we go.
Yeah.
Okay. All right. So so I know this is the wrong thing to do, but I'm gonna do it anyway. So this is I'm kind of workshopping this content right now. The talk isn't complete yet. So one of the reasons I was glad to do this tonight is I actually would like some feedback on some things. Well, I don't want to reveal too much of what I still think needs to work on it. But if you see anything that you don't think is right, or if you just want to take some notes for me, I'd love to collect those at the end. Because I know that there's things that need to change in this so far. So I won't be offended by it. So if you can pay attention, I certainly do appreciate it. All right, having said that, I am going to start presenting. Sorry, somebody just tell me, was anybody in New Orleans the last time Big Elixir happened and I gave a talk? I don't remember if I saw anybody here or there. Okay. No worries. So, all right, this title, as Brett said, is called The Phoenix Project. Subtitle, Live View and the Theory of Constraints. You can't hear the sound right now, but I'm gonna have some walk-up music. Let me see if I can play something for you. Can you hear that okay?
Yeah.
Okay. Just long enough for you to get the point. All right, so the idea is that I will walk on stage to some walk-up music. So that's a reveal. So this is so New Orleans is a city that's famous for its music. So I chose this local New Orleans artist to walk in with, and so his name's Mystical. the design of this CD is by this company called Pen and Pixel Graphics, which was the house design firm of No Limit Records. So it looks familiar. They did this one and this one and this one, but they seems like they're not doing as well nowadays as they were before back in the 90s. This is their current homepage. So hang on one second. Let me pull up my presenter notes if I can. I might not have them. All right, give me 1 second.
So Todd, is this basically going to be a series of CD covers?
Yeah, so far,
Cool.
you know, I like to, so when
Nothing
I get
wrong with that.
started,
It's good.
when I get started, I'm like, I need a lot of slides. So I just start filling in the easy ones first. So then that turns out to be my first 47 slides. And then I get to the actual talk. Okay, now I got my presenter notes up. Let me continue. All right, so we're not here to talk about CD covers. We're here to talk about the Phoenix project. But let me introduce myself first. So this is the first gag. So I'm Todd Resudek, super simple on Twitter. I'm a staff engineer at a company called Jack Pocket. I grew up in Wisconsin. Anybody from Wisconsin? Nope, close by.
People from Minnesota, but we're not going to hold it against you.
Yeah.
Yeah,
it's
I'm
quite-
from Wisconsin.
Oh yeah. Forgot, Mark. All right.
Well, I
so-
was born in Michigan, but yeah,
Oh,
Wisconsin.
don't tell people
Oh,
that.
sorry, you didn't hear that.
All right. So I grew up in Wisconsin. Then I moved to Los Angeles. Does anybody know who this guy is? Tough crowd. Okay. Then I moved to New York, and now I live in Colorado. All right. So the talk is called The Phoenix Project, Live View and the Theory of Constraints. And it's a reference to this book. So it's a pretty popular book, so I'm sure some of you have read it before. So it's sort of a tongue-in-cheek reference to this, but the part of this book, the big part of this book, talks about the theory of constraints, which was a concept that was introduced in this book called The Goal. And we're going to go a little bit into that theory in this talk and apply it to a software project. So while we're at it, I make some references from a couple of other books like this one, Accelerate, and this one, Team Topologies. So some of these things might be familiar if you've read those books. All right, so let's get started by defining some concepts. So the theory of constraints. The theory of constraints is a management paradigm that views any manageable system as being limited in achieving more of its goals by a very small number of constraints. There's always at least one constraint, and theory of constraints uses a focusing process to identify the constraint and restructure the rest of the organization around it. Okay, so this is kind of heavy stuff, but basically in any system, there's one step that's the slowest, and you can think of that as being the constraint. And this process involves identifying that constraint or the bottleneck, and then changing the system to increase that step's throughput. Once you do that, now you move on to the next thing, which is now the constraint. So if you're visual, you can imagine it this way. So we've got a certain amount of throughput at the intake, and then more at step one, and then step two you see is the smallest. So that has the least throughput, and then 3 in completion. And so if you're looking at the system, you really want to focus on step 2. Adding capacity to step 1 or to the intake isn't going to increase throughput in the system. And so this is a concept that's used in lean manufacturing. So if you've read about lean manufacturing, you've probably heard this before. But essentially, the only thing you can do to make this system run faster is to increase throughput at that bottleneck. Anything else you do is a waste of time. And then in some ways, it's actually counterproductive. So if you increase throughput at step 1, for instance, you're just going to end up with a big backlog of whatever is being created in step 1. So it could be backend tickets, it could be widgets, or sub-assemblies for a car or something. So you're gonna end up with a huge stack of these that are waiting to go through step 2. So the 5 steps when, in the theory of constraints to deal with these bottlenecks. 1, you identify that system's constraint. So in that case, with step 2, you exploit the constraint, which means that you eliminate everything that doesn't add value to the customer or the end product. Then you subordinate everything else. So this is what I was talking about. It's kind of counterintuitive, but you put all your focus on the bottleneck. You don't worry about making step 1 more efficient or the intake more efficient or the output more efficient. You only work on making the bottleneck more efficient. And you elevate. So you devote more resources to the constraint. And then once you've done that, you go back to step 1 and figure out what the system's constraint is now. And just to elaborate a little bit more on the subordinate part, like I talked about, you don't want to invest any more energy in the steps before that. Part of the reason why in an agile process is if you find that there's a flaw later on, now you have 300 of these sub-assemblies instead of 3 of these sub-assemblies that all have that flaw in them. So ideally, you want everything moving through the system at the same speed so that as soon as something goes wrong, you can adjust it downstream and you don't end up with a bunch of junk, basically a bunch of parts that can't be used or just a bunch of extra repairs that you've only found out about at the end. So how does this look in the software development lifecycle? So let's say your constraint is the front end team. It's a back end group, so I assume we can do this just fine. Are there any tasks on the front end team that are unnecessary? Is there work that they're doing that's not providing value to the customer or the end user? In this case, we would subordinate. So we would say that tell the backend developers, instead of working on building this stuff out, front end team is behind, work on some tech debt things. And in the goal, actually, they actually talk about keeping those systems in this factory idle. So if you were on step 1, they say it's better to have these people just be idle than working and building more of their parts and building this sort of backlog of things. In our case, I think there's usually work that wouldn't have to go through that same system, like going through front-end developers in order to provide value to the customer. So we would subordinate the back-end teams to do that stuff. So tech debt work, upgrading dependencies, stuff like that. And then maybe bring in more front-end resources. So we invest in front-end so that they can increase their throughput. All right, but what if we didn't have a separate front-end team at all? That's where this book comes in, but we'll get back to that. So the easy question would be, won't that just put more work on the back-end team, and won't the delivery time essentially be the same? So if you're saying just move the front-end work to the back-end team, well, it's still going to be a lot of work, right? So won't we essentially just be having the same amount of team or same amount of time spent on working, but just have it be on the backs of the back-end team instead of the back-end team and the front-end team? And the answer is probably not. And let me explain why. So there's a few reasons. The first one is the communication structures. So team size matters. This is the best size matters thing I could come up with. She'll like it too. I don't know, I'm working on this, but all right. So larger teams require more communication structures. So that's overhead essentially. This is, well, I'll get to that in a second. So you would apply Brooks' law to this. So Brooks' law is an observation about software project management, according to which adding manpower to a late software project makes it later. And that was coined in the 1975 book, The Mythical Man Month. So according to Brooks, under certain conditions, an incremental person when added to a project makes it take more time, not less time. So I think this is a 45, 47-year-old book now. And I don't think this is too controversial. I mean, I've heard people talk about this for quite a while, so I don't think anybody's arguing that adding people to a project can sometimes make it slower, not faster. And one of the reasons for this is this combinatorial explosion. So the additional overhead of the communication on larger teams, will affect how fast they can move through things. So this 5-member team has 10 connections total, and this 8-person team now has 28 connections. So if you want every member of the team to be able to communicate with every other member of the team, you get this exponential growth of overhead. And so, for us as distributed systems engineers, this should be really familiar to us. Like if you have all these nodes in a cluster, you start to see that the network traffic used just to speak to each other, can sometimes get really out of whack. So it's not add a node to a cluster and you get linear growth and throughput. You have to factor in this combinatorial explosion of them talking to each other. Sidebar, if you're doing that, check out Partisan by Christopher Micklejohn. I think it's a one solution to this, but that has nothing to do with this talk. Another thing that might come into play with the bigger teams is Dunbar's number. So Dunbar's number is a suggested cognitive limit to the number of people with whom one can maintain social relationships. So the strongest form of communication happens in an individual team working closely together with a very consistent shared context and specific purpose. And in software, this number is supposed to be 8 people. So anything more than that 8-person limit, it becomes impossible for everyone to kind of keep up with what everyone else is doing. And so that could be another problem with this, like with communication structures that could affect the overall throughput of a team. So essentially, like the fewer developers you need on a team, i.e. if you take out front-end team and just have the back-end team do things, it can keep you closer to this ideal number. And therefore you don't run into like a lot of these same communication structures problems. All right, part 2, queuing theory. So another reason lead times might improve with fewer members of the team or fewer teams has to do with this queuing theory. And queuing theory is a mathematical study of waiting lines or queues. Queuing theory has its origins in research by Agner Karup Erlang when he created models to describe the system of Copenhagen Telephone Exchange Company. So that's a name that should ring a bell, right? Anybody ever heard of that guy, Erlang? Okay. Round of applause.
Yes.
Yay.
All right, so let me explain queuing theory real quick. So this is like a visual diagram of what Erlang describes. So you've got incoming traffic on this one side, and you've got some queue system in the middle, and then you've got these service channels on the other side. And so like a more practical example would be you have all these customers that are in your store, you've got the queue, the waiting line, and then on the output side, you've got these cashiers. So you apply Little's law to this. So the long-term average number L of customers in a stationary system is equal to the long-term average effective arrival rate lambda multiplied by the average time W that a customer spends in the system. So expressed algebraically, it's L equals lambda W. So let's imagine like a small store with just one cash register and assume everyone that enters the store is going to buy something. So if the arrival rate is greater than the exit rate, the queue size eventually approaches infinity. And this is the same thing that happens to your backlog. Your arrival rate is much greater than your exit rate. All right, but how do we apply this to the software development lifecycle? So here's an example. So let's say you've got, instead of customers, you've got Jira tickets coming in, and then your queuing system is your sprint commitment, and you've got developers on the outside. They're your cashiers. Now, this is where the developers are. This is going to be your bottleneck. Jira tickets are arriving faster than they can be completed. Now let's break this into two teams, a back-end team and a front-end team. And what happens now is you've got two queues. And this is what a diagram of two queues looks like. So you've got, Jira tickets coming in, sprint commitment, back-end developers, and then those go into front-end Jira tickets that go into their sprint commitment that go to their cashiers, the front-end developers. And so now your system has two bottlenecks in it. And like I talked about in the previously, if there's any errors in this process, they aren't discovered until really late. And so if you can imagine, like the front-end developers find some error in the code or some extra data that they need their API to be decorated with, for instance, you're not going to find out until almost the very end of this queue or this queue system that needs to happen, and then you go back around. So that leads us to talking about flow. So this is how I would describe work moving throughout the system. So you've got your requirements, and those flow into this backend work, and the backend work flows into API work. So if you think of like the backend work being your Elixir or your Phoenix app, and then you've got the API, which is like your contract with the front end team, and then the front end team has their HTTP client, which is kind of the other end of that contract, and then they apply that to their front end app, whatever it is, and do all the UI. So in a factory, you'd see these and handles to alert between each of those phases. So I don't know if anybody's ever worked at a place with these and handles, like either real or metaphorical, but the way that these work, I think these were invented or are invented as part of the lean manufacturing process and implemented by Toyota. So if you're at a workstation and something comes up, or you see a flaw in the parts that are coming to you, you hit this red light, you stop the whole system, everybody stops working and focuses on what your problem is before moving on to the next thing. So let's say in the software development lifecycle, you've got all these steps, and then there's a problem with the API that doesn't show up until the UI. You say, oh, hey, I needed this float rounded to 8 places instead of 4 places. So now what you have is they're pulling their proverbial and handle. You go all the way back to backend work, or maybe the API work. They have to restart again, and then we can keep the flow moving from there. So you skip back 2 or 3 workstations before you can continue working on the UI. And now if we were to break this into just a backend team that was using live view for everything, your flow looks a little bit different. So you've only got these 3 workstations instead of 5. And so if something comes up in the UI work, you're only going back to the previous workstation. And in this case, it's the same group is working on it, or it might even be the same person. So that person that discovers the problem with that float in the UI side of things also could be the same person that's fixing the API on the backend work, or at least it hasn't moved that much farther through the system. So I think that makes it more efficient. Another issue that could slow down lead times in the system is complexity. So one way that this complexity affects you is in cognitive load, and everybody has a limit. So no one's immune to cognitive load, and it is broken down into 3 parts. So there's this intrinsic load. Sorry, let me define it. Cognitive load refers to the amount of working memory resources being used. So there's an intrinsic load, which is the inherent difficulty of the subject. So if you are, finding prime numbers or something, or you're working through a difficult problem, that's the intrinsic load. There's a germane load, which affects a different part of your brain, which is the part that's devoted to integrating, synthesizing new information that's coming in. And then there's the extraneous load, which is all the unrelated matters that still require some of your brain power, some of your attention. So a complex system is impossible to entirely reason about. So if a sufficiently complex system, no one can really reason about the whole thing. So any reduction in the complexity of the system will decrease the cognitive load of the people working in it. So if we look at the anatomy of this traditional app that I've been describing, you've got, you know, your Phoenix app, then you've got the API code, and then you've got HTTP client code, and then you've got this React app. And obviously this is pretty simple, but in this case, you know, the cognitive load is pretty high because you just have a lot of code in this type of system. So you've got a high cognitive load, and it makes the system more complex, and thus it makes it harder for everyone to reason about. Now, the anatomy of a live view app is a little bit simpler. So you've got a Phoenix app, you've got your live view code, and that's it. You don't have the API code anymore. Necessarily, you don't have the HTTP client code anymore. So overall, you have less code. Not only that, the code that you have is all very similar. So one thing that's really nice about live view is that these are your callbacks, and they look really familiar because a lot of these are the same callbacks that you see in gen servers, a concept that, you know, most backend developers are going to be familiar with. So overall cognitive load, like figuring out, you know, what is the pattern of how a live view works? What's the life cycle of a live view versus what's the life cycle of a backend request or a process that we're running in Elixir? They're very similar. So the cognitive load overall is very small, or much smaller than it could be. So there's less context switching, even when going from, you know, app code, deep backend code, all the way up to your front end code. You're always working in these same, you know, handle calls, handle casts, handle infos, etc. So backend and UI are very similar. Sorry. All right, so that's my case for using live view instead of building an SPA. So let's talk about the implementation. How do I start? So there's a lot of work to do, but the one thing you want to keep in mind is Conway's law. It's not that Conway, by the way. This is Melvin Conway. So Melvin Conway has a PhD from Case Western Reserve, 1961, go Spartans. He developed the concept of coroutines back in 1958 and worked on the spec for mumps and published the mumps manual back in 1983. So I know that some of you are familiar with mumps, but if you're not, it stands for the Massachusetts General Hospital Utility Multi-Programming System, which now that I say it, feels like somebody came up with the acronym and then tried to jam in what the words were after the fact. But you'll still see this used if you work in medical system. There's even some financial systems that use mumps. But if you like ever go to work at the VA or some big medical system, especially an old one, they might ask you to program in mumps. All right, so the Conway you were thinking of is this guy, John Horton Conway. Different guy, PhD from Sydney Sussex College in Cambridge. Don't think they have a sports team. And the creator of Conway's Game of Life in 1970. Incidentally, he's also famous for working on combinatorial game theory. So that's a branch of mathematics and theoretical computer science that typically studies sequential games with perfect information. So a good example would be tic-tac-toe. So pretty simple game where it happens sequentially and you always have all of the information at any given time. All right, so now that we know we're talking about the other Conway, Conway's law says any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. You need to internalize this. Even if you don't use live view, this still applies to you right now. So this is a quote that I found about it that I think makes perfect sense. So if you have 4 teams working on a compiler, you'll get a 4-pass compiler. That's how this works. So so Conway's law dictates that essentially you will end up producing a system that reflects the communication structures of your organization. So if your HR team is deciding who goes on what team, your HR team is essentially your de facto architect for your system. If a manager is doing that, your manager is your architect. So you need to be very deliberate about how you build the teams, how you design the teams. And occasionally, when they don't fit the architecture you're looking for, you're going to want to implement what's called the inverse Conway maneuver or reverse Conway maneuver, where you redesign your teams to match the architecture you want this project to have. So before you start, you say, switch these teams around so that eventually they're going to produce the output that I want, which is this architecture. So, like I said, this is my strongest advice if you're thinking about rebuilding your teams to switching to a live view, this live view pattern that I've described. All right, some caveats like why could this be a horrible idea? Why you wouldn't do this? So you actually want to put work onto the client. So, live view basically puts a lot of work on the server side, makes the client side very simple. But if there's a case where you say, no, I want to offload a lot of this work to the clients, live view probably wouldn't be a good solution to that. Although the recent trend that I've seen in React is to move everything back to the server side. So I don't know how much this would apply, but in 2 years, they might be back to putting things client side. And if you really wanted to do that, live view probably wouldn't be a good fit. Obviously, less access to libraries. So the JavaScript ecosystem has tons of libraries that do everything you need them to do. In the live view world, there's much less of that. And so you're going to be rolling everything yourself. So keep that in mind. Make sure your team is willing to do that and able to do that. And another thing probably shouldn't be overlooked is live view hasn't reached a stable version yet. So it's possible there might be an announcement by the time this talk comes out, but the latest live view is 0.17, I believe. And I think there's a 1.0 on the near term roadmap. But we've seen from the early versions, every 3 to 4 weeks, there would be major breaking changes in live view. And we've even this year, just with the transition from 16 to 17, saw some huge changes in the templating system and some additions and some modifications. So you are building off of a non-stable, a 0-point release. So keep that in mind. There's going to be some probably going back and changing things, a month or 2 months from now. So that's it. Thank you. Thank you, Jack Pocket. Thank you, The Big Elixir. I'll take questions or compliments, not comments.
This is Matt. You're kind of playing into my past life wheelhouse as a CIO. And by the way, just by introduction, I was a programmer on, I don't know if anyone would remember tandem nonstop systems. They're kind of like Erlang and hardware. But I programmed on those for about 18, 19 years, then went into management. Retired recently, and I'm learning Elixir to just spend the rest of my life working on open source, if I can. So real quickly, when you describe something like this, the first thing that comes to my mind is, what is your diagnostic tool for figuring out you even have a problem? And why a bottleneck is a bottleneck. And oftentimes a bottleneck exists not because it's a bottleneck, because it's response to its surrounding environment. So that's just the first thing I'm thinking, because in my mind, I got to translate this into dollars. When you say that live view is more efficient, I want to be able to say, well, shit, I can get 3 more FTE now. I mean, that's kind of how I want to think about it, to make a decision to put that technology into a team or my organization. So I thought of that. That just came to mind. So no particular order. Let's see. The thing on complexity, we could probably have an offline conversation on that. But I just think that overall, just having a context where you can measure that you have a problem, know where the bottleneck is, why it exists, know that even if you free up the bottleneck, you might necessarily break other processes. So thinking in terms of business process modeling or something like that, which I have extensive background in, I can, if you're even interested in it. And then the other thing that you brought up, the queuing and all these other things, the thing that came to my mind was, okay, great. So what? What does that mean to me? So the things you brought up, I think, are critically important, but I'm more interested in why it's important to me versus its definition per se.
Yeah.
And things like that. So, you know, and some other things have come to mind too, just because I can't tell you how many technologies I've had to sell to management. So enough said. I'm sure other people have similar experiences that can chime in.
So it's a load, Matt. Let's see what Todd has to say.
Well, first thing I wanted to say is congratulations for retiring and being able to dedicate your time to open source. It's like I think it's a dream for a lot of us. So congratulations on that.
Appreciate it.
So I think, first of all, I think a lot of what you said, I agree with completely. And I do think one of the things that I'm still missing in these slides is this, a more of a greater narrative that kind of ties everything together. So like a story of an actual project that would be able to like make these more real examples. I feel like there's a disparate group of kind of artifacts of information, but it still needs that like strong narrative that ties it together. So I think a lot of the things that I wrote down that you said are kind of fit into that problem space. So I don't know if I necessarily want to get into measuring like the bottleneck. I think it's important, but I just don't know if I'd want to do it in this particular talk. So I think you're right. Like, well, it's sort of implicit, right? You don't know anything's a bottleneck unless you're doing some measuring.
Right.
So it's sort of implicit, but I'm going to stew on that. I don't know if there was.
Well,
was there?
you could just go with just a recognition that the bottleneck exists for some set of reasons, and an investigation into those reasons, you know, causes and conditions, if you will. You know, it just is an appropriate exercise. And then you can just go and say, well, let's just assume we've done those things, and you know, this is a bottleneck or something of that nature.
Yeah. Okay, that's good. I like that. I don't know if there was any specific questions or if that was more of a stream of consciousness comments.
Yeah.
Okay. I just want to make sure I was answering if you had a specific question.
So Todd, this is John Unruh, the other retiree here, who also has experience in corporate management, small business management, blah, 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 blah. Anyway, just first a comment that there was a really good layout of this bottleneck analysis in one of the computing surveys from the ACM around 1980. And I actually happen to have used that once or twice in real life. Second is, I think, following up on Matt's comments, having been in the same kind of position, you're asserting that somehow all this stuff supports using live view rather than React or Vue or whatever. But you're giving us no evidence that that's the case. None at all. And so I think it's, while you identified some things that might be a bottleneck, you have no case that live view does any better. one of the reasons the goal, I think, as a book was so successful was it was the story. It was really about industrial engineering, and it was a story of improving the profitability of the factory and going against the cost accountants in doing that.
Comment on that same thing of like something that we've run into is that the DSL that Phoenix LiveView uses, it self-imposes an additional cognitive load on our developers, especially front-end developers that are familiar with React. Like the mental model doesn't know one, so they're unable to reuse built experience because the edge cases are different and it burns in different places. So that's something we've run into.
Yeah, I agree with that, and maybe I should make it more clear that my my suggestion here is to not have the JavaScript people doing LiveView, but having the Elixir people do LiveView. And obviously the DSL is very different from React, but the DSL I was trying to point out is very similar to Gen servers. Now that's going to leave a lot of front-end developers out to dry, but it is an Elixir conference, so I'm not too worried about offending those people.
But now in real life, you were, to cut John Unruh again, coming up against some of the stuff that's actually behind Conway's law. One of the reasons that the software tends to mirror the organization is each organization is trying to maximize itself as part of the larger organization. And traditionally that meant having more people in your organization, but you have more power, you get to a higher level, because once you split it all out, right, there are 10 people to each manager, 10 managers to each manager, and so forth. And so if you have 100 people, you can be at a higher level. So if you do something that's going to essentially wipe out the front-end developer part of your organization, you're going to come up against major internal political stuff, because most of the time people are not out to help the customer the most or help the company the most, but help themselves the most.
Totally agree. Yeah.
Not most times, all times.
Yeah. Yeah. Well, you're right. Keep in mind that the opposite of complexity is familiarity, and people are going to stick with what's familiar. And so moving around familiar and giving them, as John pointed out, a path they might not have thought of to glory is kind of the way you sell it. And so the nice thing about Livebook is it can make all the players with their existing skill stack, if you will, give them a capability that they just previously didn't have. I think when you play around with cognitive load, we get, I don't know, it's just, to me, it's become, I don't know, I wrote my first program in 1978. So I just feel like, having stayed with the technology all these years, it's just a matter of skill to keep up with things. And so I just think cognitive load is just, I'd stay away from that, and I'd just go, what's the cost of acquiring new skills? And LiveView is a nice, at least from what I've seen of it, it's just a nice technology leap over the existing stuff. And keep in mind, anybody that implements LiveView is going to be retooling older stuff. So they're going to have to know the other things. They're going to have to know the existing stack, and take an old Ember app and move it into LiveView, integrate it with other stuff. Those people are still going to be necessary, just like, if you're in a banking system, poor people are still writing COBOL. So, just a thought there. But I like the idea, and I like the storyline. I like the storyline. It can be totally developed.
I think,
Todd, Sorry,
Sorry.
real quick on that level. As a writer and an editor, I 100% agree with your take that a stronger narrative will pull this whole presentation together. All of the good presentations that I've ever seen are not about the information. It's about the story that delivers that information. And so if you can make that a strong narrative, I think it'll tie your whole presentation together. And one quick direct question from a non-developer, non-coder, how do you know that you are identifying and isolating the correct constraint or bottleneck at the right time?
Yeah, so I think there are always going to be evidence of where that bottleneck is. If you're in a factory, it's basically the step after the step that has a ton of extra product at it. So I've got all these million sub-assemblies. It's a pretty good indication that the next step in the manufacturing process is the bottleneck. It could be different, but you would, I think that there are always going to be, it's always going to manifest in ways that are easy to measure. In this case, I would say it's going to be like looking at your Jira swim lanes and seeing there's a ton of front end tickets ready, and they're being bogged down. So there's always this approaching infinite number of API tickets that still need to be implemented on the front end. That's my experience with things. Now, as far as cognitive load, not that I need to defend myself, but I do think I don't think I know that every person has a capacity. So I don't think it's as easy as saying, well, if you're just a smarter person, you can know all these things. The fact of the matter is you cannot be a great COBOL programmer and a great JavaScript programmer and a great Golang programmer and a great person at the same time. You got to pick something, or you're going to be kind of half-assed at all of them. And that's not anything against you, assuming that you are still a member of our same species. So assuming you have to have
it's always been that way.
Yeah, I mean, humans, I think, are always that way. So if the front end code mirrors the back end code more, then it would stand to reason to me that the cognitive load of knowing how to do a front end and a back end is going to be overall less. You don't have a different set of tooling. You don't have different set of libraries. You don't have different DSLs. You don't have different patterns, architectural patterns. So
that's a false argument. The way you've posited that companies are structured with a front end team and a back end team, because the front end team needs to know JavaScript or ClojureScript or whatever, and all the tooling that goes with it. The back end team doesn't actually have to know that, and vice versa.
Right. Just driven by APIs.
So, hey Todd, I've got a question on that. So, a couple of your slides were talking about how you organize your teams and how that kind of lays out the architecture of, I'm thinking of probably a product team is what you're talking about there. So I'm thinking about in a world or in a team where you have, say, I don't know, 5, 6 developers, and say it's roughly half people are half of your team is more comfortable with front end, or that's what they do on a day-to-day basis. The other half is more comfortable or more knowledgeable in back end. If you're moving to a live view architecture, how do you think about reassigning work? Or is it just kind of training everyone on the skills they're lacking? Or do you kind of divide the work in a different way with that kind of team?
Admittedly, my theory here is that you don't want those people to begin with. So in theory, there's a different team for them in the organization somewhere. But this is all based on the premise that you would just use the same back-end people, or you would say, I have a headcount for a team, and you would say, well, give me 6 back-end people instead of 3 back-end people and 3 front-end people. And again, front-end people don't like being told that. And that you wouldn't want to show up to work and be like, hey, F you, get lost. But it's, again, an Elixir conference. So I'm not worried about hurting their feelings. Now, if we went to a JS conference, they would be like, we should be doing all this in Node so that we can do TypeScript for everything. Also a very valid argument. But hopefully nobody that I work with makes that argument. Or hopefully I make my argument before they do.
But actually you have a different argument. The argument you're making is not so much, is somewhat about languages, but the argument you laid out was really more about eliminating things that you posit are a bottleneck, like the HTTP between the client and the server and the development of the API rather than language issues.
Say it again.
So the way I understood your argument is that the bottleneck had to do with the steps that you were eliminating, like handling HTTP requests and actually building the API and handling the API on both ends and the errors and all the stuff that goes with that. And the validation twice, once in the front end and once in the back end. That I thought was your description of the bottleneck. That really doesn't have anything to do with language directly. It has to do with having all the information basically done and handled in one place instead of in two.
Yeah, I would agree with that. It's more like streamlining the factory, like doing the, tempering and the powder coating in the same step instead of having two workstations. But I agree with that. I don't think it's language specific. It's maybe somewhat forced because this is a LiveView themed conference. So I would agree. I would say that somebody could flip this on its head and say, do this all in TypeScript, and it would be as equally valid, whether that's good or not, argument. So I agree with you, John.
Except that would assume that Node has some facility for driving the front end without any significant amount of actual in the browser JavaScript.
JavaScript framework, though, Next.js or something like that, isn't that right? Right?
Yeah, that sounds right. Well, yeah, so maybe, I don't know. Node is just, to me, a backend framework that uses the same language. But yeah, Next.js, or I don't know what the framework du jour is, but I'm sure there is one.
Maybe a better analogy there, Todd, would be like the current process is building a set of parts and then packaging them all up and shipping them to another factory to do some more work on them. And you're completely removing all of the packaging and shipping out of that process and doing everything in the same factory.
And the cool thing about that analogy, Solo, is that you have to determine whether or not that in fact is your bottleneck in the first place. Because if it isn't, then this is all misplaced effort, as per the first part of this talk, right? It may make sense based on your own organization to actually keep a front-end team because you're not actually running into issues in this particular portion of your workflow.
Yeah. Okay, I think that's great.
I have one more anecdote too, because what I found too is that your front-end engineers are almost like even if they're on the same product team, they're almost like the separate like mini team within a team. And they have their own priorities and things that they're working on too, even though you're all kind of working on sort of the same features, but you have there's a little bit of mismatch there. So like even if you finish something, quote unquote, on the back end, and then they get to the front end in a month or in 2 months. And then like you realize, oh wait, we missed a field when we go out and build the front end. So now you need to I need to go back and remember, what did I work on 2 months ago? What was the field? What is it? How does it relate? And then I have to relearn some of that stuff and then rinse and repeat.
Yes.
So a couple of thoughts on this. Thing number one, in terms of the bottleneck question, perhaps a better argument for using the same language for front end and back end is actually that it allows more fluidity in terms of you're talking about how when there's a bottleneck and not necessarily like a structural bottleneck, but sometimes it's a temporary development bottleneck. There is an advantage to having a team where everybody knows the same language that's used in the front end and the back end. because it does mean that you can redistribute people and you can say, oh, hey, you know what, we've got a real bottleneck right now on the front end. We got to kind of swarm on that. We'll allocate more development time to that. Cool, we fixed it. Now we're going to work on this back end feature. So that's one thing that it really does give you. The other thing is, in terms of Conway's law, something to bring up is the way that we're talking a lot about sort of, you've got a big existing app and, oh, maybe we're going to switch it to live view. I think that's maybe not especially considering the stage that live view is at right now, it's maybe not the ideal case for it. I really see live view as being ideal for, say, when you've got a newer product that you're putting together, you can put something together with a smaller team that only knows Elixir, and and everybody can kind of work on the front end and back end. So a small team can do a lot. And eventually you'll probably move to, hopefully you'll grow, and you may just eventually, I don't know whether it's live view that will, continue to grow, hopefully, or potentially, you might just grow out of that and once again need to split it up into more separate teams, and then you might just need a dedicated JavaScript oriented front end team, in particular because straight up they're just things that are, you reach a certain point where you can't do everything in live view. Even if you're using live view primarily, you're still going to have to write some JavaScript.
Yeah, I think I like those examples that you gave. I'm gonna modify my talk.
Excellent point that if you have a working JavaScript front end on a large application, you're not going to rewrite it. You're only going to rewrite it if you find out that JavaScript front end is a huge bottleneck that you can't easily fix within the realm of what it's already doing, or you don't have one at all and you're trying to figure out what to do. And live view might be a choice that you would make instead of doing React or something like that.
Yeah, I think being greenfield project, I think that hits the nail on the head as far as this whole narrative goes. It's going to be a lot easier to sell, and I do think it makes more sense for the examples that I showed versus, obviously it's very contentious to say, yeah, rewrite it all, get rid of half your team, that sort of thing. So I think that's key, Byron. I'll give you full credit for that.
Yeah, for what it's worth, we're in a situation where we're going to have both live view and React for the infinite future. We ship an SDK to a third party, so there are ways that we could hack around doing that in live view, but I don't know that we're prepared to take on those hacks. So part of our product will be delivered as an SDK, but then the internal tooling that we write is all in live view. So I think that's a model that you'll see come up.
Well, also keep in mind the argument about the back end and the front end being, the same technology. I mean, take a look. Well, when I first played around with JavaScript, I learned Meteor, for that same reason. And we can see where that one went. It went nowhere. And so, echoing what John said, language is not the issue. It's the domain of who makes decisions and within organizations and what they feel comfortable with, so that they personally can win, and then downstream their teams can win. I just see live view as a force multiplier. I see it as something that can provide additional alignment within the technologies and the desires of the particular outcomes of the departments that are serviced by their IT people. It can, again, make them, or provide some capability of making them potential heroes. Do more with less. Got to play with budgets, got to play with staffing, got to do all this kind of stuff. at the end of the day, it's always been a psychology game. It's not, it has nothing to do with my language. At least it's been my view, my personal experience. And I've made some of those decisions myself, so I'm more guilty of that. So, I still think I forget who said that, it was Jeff maybe, that it's the narrative that you want to really develop, and that storyline, and kind of don't be as committed in the narrative to a particular technology, other than LiveView gives you capabilities that you just simply don't have today, and again can provide additional alignment of technologies and can be kind of like a force multiplier. That's kind of how I think of it.
Yeah, absolutely. I would also just encourage not being dismissive of JavaScript developers in particular, or even JavaScript. I think all a lot of us prefer, for example, Elixir over a language like JavaScript for reasons. But definitely my view is, first of all, like every language has its trade-offs. At any given point, you're choosing this over that because there might be things I like over there. Wish I could have them in Elixir. Can't have them, but I overall I like the tool set that I get here, right? So that's something to keep in mind. And I do think that JavaScript has suffered from two things that have given it like a bit of a poor reputation. One of them is that the language started off in a pretty janky way. It's gradually getting better. Two is that it's a very common language for people to learn first, and without a lot of necessarily guidance, which can be both good and bad. So you've got a lot of crazy stuff that ends up getting into NPM and so on. So it's easy for us to get dismissive, but being a very good JavaScript developer, I do want to underline, is a hard thing. And so someone who's very good at JavaScript can definitely become very good at Elixir, given the right motivation and whatever. It isn't really, I don't see it that it's hard to go in one direction or the other, to be honest. So I would just definitely, for a talk, I would want to kind of insulate, even if there are some people who would be like, yeah, rah, 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 Elixir is awesome, JavaScript sucks. Yeah, of course that will exist, but I think it's just good to stay away from those kinds of from being part of that kind of discourse, just in general. Even if you have that feeling of like, oh well, we're all amongst friends and we can hate on other languages, yeah, maybe a little bit poking fun, but be really cautious about the difference between like, oh, we like this thing versus like, those people suck, we don't need them. I definitely wouldn't go. I wouldn't go within 10 feet of that.
I build on top of that, is that the frameworks that are built into the browsers are awesome. You can hook into those with LiveView, so you don't not write JavaScript. You just don't have to rely on some of these other frameworks. You can just write vanilla JavaScript, and you can do some pretty awesome stuff. And I think that's I think it's lost a little bit, but I think the JS commands that's new, be able to plug into that stuff directly, opens that up. So then, yeah, I go to the Mozilla docs and find out what that API does, and then hook into it with my LiveView, and you can get very, very compelling front end experiences. So you don't you still need to know JavaScript. You still need to understand browsers. You still need to understand front end concepts. I can't remember who posted that in the chat, but you still have to do all that stuff. You still have to know that stuff. But then if your team wants to say, hey, I'm going to work on, getting some, work on ecto models and context, modules and things like that, and somebody else can focus more on interaction, you can definitely split your team up a little bit more like that. But you would have the ability to like, oh, I want to add one more field. I can go ahead and do that in my schema and stuff like that.
Yeah, sorry if I projected that at all. I don't have anything against JavaScript. It's extremely hard to do JavaScript well. I do think it's really hard to be a really great JavaScript programmer and a really great Elixir Erlang programmer at the same time, just because it's hard to devote your brain to two somewhat different things and excel at both of them.
Yeah,
Todd, as somebody who knows you pretty well, I recognize that you were ultimately just trying to be silly when you were saying it's a Elixir conference. And I read it that way, absolutely. But yeah, just this is a good reminder that we just have to kind of think about our audience when we say things.
Never been my strong suit, Jeffrey.
It has never been your strong suit.
As you know, as you know.
but I
The
think there's
testosterone booster being one of them, right? The
Well,
testosterone booster slide.
You know, some of us like myself, like I've had to, you know, wade through some, you know, some challenging situations, you know, with people disagreeing about stuff in the past. And so you know, it wasn't necessarily a like even a personal concern with you, Todd. I don't know you. It was, you know, you're trying to make this into a great talk, and that's my advice is just to. It's a thing that when you're giving a talk amongst your friends, people might not think about that, but when you look at it from the external view, they're like, oh, who's this guy? You know, why is he hating on? You know, maybe you're you've been a JavaScript developer for like 10 years, and you're just starting to wade into Elixir. You join the conference, you're like, why is he hating on us? You know, and so you just want to be, you know, at the very least, be cautious, and I think it's okay to joke around, but yeah.
No, I
just-
agree.
just good to keep in mind.
I appreciate the feedback, Byron, because I don't want to project that, even if somebody can misunderstand it if I'm joking around. So I agree with you 1,000%.
And to be truthful, like Todd, I saw your ElixirConf talk, and it was by far the most entertaining talk at the whole conference.
Thank you, Don.
No way to suck up there. Nice.
I think there is a trend also that is happening in the industry, which is pretty much maybe, you know, a copy of what, you know, LiveView is trying to do. Like in, you know, Ruby on Rails, it all started with just, you know, developing your views in the templating, you know, language, which was Ruby at the end of the day. And people then started to move to using more of the JavaScript, you know, front end. And then there is a pullback of sorts. I think there's a copy of the live view that is happening using Hotwire and Turbo Rails. So basically, you just like you code everything in one language, right? So that goes to your point, Todd, to reduce the complexity, the cognitive overhead, right? And obviously that takes away the jobs of the front end, you know, guys. And you know, sometimes, yes, I mean, to create something very complex, maybe, you know, using one language may not be the greatest idea, and maybe, you know, JavaScript is the way. But I'm saying, like, you can get at most like 80 to 90% of the way with one language only, like whether it is Elixir or you know Ruby, now that we have, you know, WebSockets and all that stuff, and pretty good ways of just throwing in a code and making things work like an SPA. So there is definitely, you know, a decrease in the cognitive overload.
True.
Yes.
Do you have a case, Todd? So I'm thinking about like a constraint for this talk that might like clarify some things. Like, so when the only bottleneck that I think you covered was basically like a productivity bottleneck for like teamwork. It's not like we're not talking about database bottlenecks or like Broadway or anything like that. So, so it's not like a diagnostics talk really. It's more of like a
Uh-oh. Did you freeze? What happened?
Okay, thank you. I was applying sort of this arbitrary bottleneck that existed. Like, let's just say, for example, the bottleneck was in the front end system. And then here's a solution that you could apply to that. But in real life, there's no reason to think that the front end team is any slower than the back end team. In fact, it's probably
back end.
is slower. I don't know.
Typically, larger enterprises, you're dealing with, all kinds of integration problems. The front end guys can typically turn things around on a dime. It's been my experience, especially you're dealing with large databases. I did some consulting for Uber. One of their data centers is up in just north of here, and all I can tell you is that they just don't go willy-nilly putting in something when there's terabytes of data to deal with. So I think that's somewhat conditional.
Yeah, I think it is. It's just totally arbitrary. So I think it's important to have a narrative like this is what happened to me in the real world. Because I don't mean to imply that front end teams are slower than back end teams, because half the time they are and half the time they aren't. And obviously your experience kind of biases towards one side, Matt. I would say mine probably biases the exact opposite way, but I think it's just random.
But that,
in my mind, the bottleneck
is the communication, the handoff from the back end to the front end, and that becomes the bottleneck.
Many times, yes.
All right, guys.
Yeah.
We've had quite a bit of discussion, which is great. I'm glad that we've been able to contribute and to help give suggestions back to Todd. So since we are kind of on a limited time schedule here, I'm going to wrap it up and move on to the show and tell portion. So is there anybody who would like to share anything with the group? That's not Todd. Thank you for sharing, Todd. You've already shared.
Okay, sorry. Can I just say thank you to everybody for their feedback?
Yeah.
Yes.
It was extremely useful. It's just what the doctor ordered. So I've got a lot of...
Well, we appreciate you showing up and doing this too. So thank you.
Yeah. Yes, everyone benefited. Yeah. So thank you much.
Cut me some slack. They got 2 days of live view talks, and I felt like a lot of people are going to be showing a lot of code, and I thought, let me go out on a limb here and try something different. So
nice.
So I do appreciate it. Thanks for the small amount of grace that you provided me.
Anything for you, Todd.
All right, I'm gonna grab family, but I love you all, and I hope to see some of you in Salt Lake City on May 6th.
Yeah, you should come. It's fun. All right.
Yeah, I plan to be there.
Oh,
job, Todd.
Sweet. Thanks again, Todd.
Bye, everybody.
All right. Anybody with the show and tell? Otherwise, we can do the breakout rooms.
I thought I was going to have something, and we just have had such a busy week. We still are a month that it didn't happen. We just got to write documentation, but we've got it. Jeff and I have a library that we're going to open source as soon as we get the docs finished. So sorry.
Yeah, it's all right. Okay, I am going to throw it open then. So we'll stop. We'll have the lady tell us to stop recording. Oops, that was not it. That was ending the meeting. Stop recording.